I welcome you to another series of our videos. If you haven't subscribed, ensure you do so. So in this video, we'll be discussing vectors. So this question we have here is coming from 11th edition Seaway College Physics and problem 67 topic 1. So the question reads, a vector has an x component of negative 25.0 units and a y component of 40.0 units. So find the magnitude and the direction of the vector. So we need to find the magnitude and direction of the vector. So this is the diagram representing the vector, because in physics you are always advised, like whenever you've been given a question, you write or you draw a simplest possible diagram representing the question. So this is the diagram, then this is the x-axis. So the x-axis of this, or the x component of this vector, is negative 25. So it means that this component is in the negative x-axis direction, like that. Then the y component is positive, so meaning it's going up. So we can tell that the vector is in the second quadrant. So this is the diagram that we have just drawn here. So if that is the case, then now this is our vector. So this is the angle which becomes our direction. So this is what we have drawn. So now let's find they want us to find the magnitude and the direction. So let's start by finding the magnitude. This is not so hard because we already have the components. So to find the magnitude, you use the formula. The resultant magnitude is given by this equation, the square root of x squared plus y squared. So where there's x, you substitute with negative 25, then you square it. Where there's y, you substitute with 40, then you square it. So when we punch this on a calculator, this is what we get. So negative 25 squared is equal to 625, then 40 squared is equal to 1600. So when you add this, you get 2225. So finding the square root of 2225, we get 47.16990566 units. So we now write this in 3 significant figures, and it's 47.2 units. So this becomes the magnitude of the vector. It is also important that we look at the direction. So to find the direction of the vector, you use the equation theta is equal to tan inverse y over x. So these are just the components of the vector. So the y component of the vector was 40, we substitute. Then the x component of the vector was 25. So we have substituted. So when we punch this on a calculator, we are getting the theta to be 57.99461679. So earlier we mentioned that this vector is in the second quadrant. So meaning we are supposed to substitute 57.9946 degrees from 108, and when we substitute, or when we do that, we get the theta to be 122.005783.2 or 832 degrees. So to write this in 3 significant figures, we get 122 degrees. So this is the direction above the positive x-axis, or making the positive x-axis as our reference point. So a summary, it's 47.2 units. The magnitude is 47.2 units at 122, okay, 122 degrees from the positive x-axis. So this is what they required us to do. So let me also just mention it again. The magnitude is 47.2 units at 122 degrees from the positive x-axis. So if you haven't subscribed, ensure that you do so. Thank you for watching.